Hello everyone, this is Alban here. Welcome back to this session of learning. This is math subject and the topic of learning is permutations. In this particular session, we are going to solve total 5 questions and this is the first question. Let's solve this. Reading the question. How many words can be formed with the letters of the word Oriental, Oriental, so that letter A and letter E always occupy odd places. Okay, so we have got the letter that is Oriental and we have two letters A and E which should always occupy odd places, and we have the four options given. Let's start solving this particular question. Let me write this word separately, letter wise. Oriental. How many letters? 1, 2, 3, 4, 5, 6, 7, 8. Total we have 8 letters in this particular word Oriental. Okay, so now just write the letters 1, 2, 3, 4, 5, 6, 7 and 8. How many odd letters do we have? 1, 2, 3 and 4. So 4 letters are having odd places. Okay, now in this particular question they have said that letter A and letter E always occupy odd places. That means we have total 4 slots. Okay, 4 slots or 4 places where odd numbers can be filled. Out of that, 2 letters, that is A and E should fill in those odd places. So our permutations, what is the permutations formula? NPR is equal to n factorial divided by n minus r factorial. Okay, so here this is nothing but n is 4 and r will become 2. Okay, so 2 letters we have to place in the odd places. So simplifying this, 4 factorial divided by 4 minus 2 factorial, nothing but 4 factorial is 4 into 3 into 2 into 1 divided by 4 minus 2 factorial is 2 factorial. 2 factorial becomes 2 into 1. So cancel these 2 and 1. Left out is 4 into 3. So answer will be 12 ways. Okay, this 12 ways is the answer of these two particular letters A and E which are placed in the odd places. Now we'll have to find out the answer for the rest of the 6 letters, right? We have 8 letters. Out of this, 2 letters we have placed in the odd places. Now we are left with 6 letters. Okay, which are those 6 letters? 6 letters are nothing but O, R, I, N, T, L. Okay, so these 6 letters have to be arranged. What is the maximum number of ways we can arrange these 6 letters? Is nothing but 6 factorial. Okay, so 6 factorial is nothing but 6 into 5 into 4 into 3 into 2 into 1. Okay, so this is the answer of rest of the 6 letters, and 12 ways is the answer of the 2 letters A and E to be placed in the odd places. Now we'll find out the maximum number of ways or the total number of arrangements that can be made. Okay, total number of arrangements. Total number of arrangements is nothing but 6 factorial into 12. 6 factorial into 12. So make use of the calculator and find the answer. 6 into 5 into 4 into 3 into 2 into 1 multiplied with 12 ways. And our answer is 8640. Answer is 8640. Look at the options. We have this option B, 8640. Hope you all understood this question. Try to solve it on your own. Moving on to second question. Let's solve the question 2 out of the 5 questions. And the topic is permutations. How many 6-digit telephone numbers that can be formed by using 10 distinct digits? So 10 distinct digits are available. Out of those, how many 6-digit telephone numbers can be formed? This is our question, and we have 4 options. Okay, so first we have to find out whether it is a permutations question or whether it is a combination question. So here it is arrangements. So we are going to find out 6-digit telephone numbers out of 10 distinct digits available. Okay. So if we are going to select the numbers, that is 10 distinct digits, then it can start from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now you can count it 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Why you have to start from 0? Because in the telephone numbers or the mobile numbers, 0 is also one of the digit, right? So we have 10 digits. Out of this we have to find out a 6-digit telephone number. How many maximum number of ways can we do this? So our n is 10 and r will be 6, and the formula for NPR is equal to n factorial divided by n minus r factorial. That is nothing but n factorial is 10 factorial divided by 10 minus 6 factorial. Okay, so let's simplify this. 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 10 minus 6 is 4 factorial, 4 into 3 into 2 into 1. Okay, this is how you can cancel 4, 3, 2 and 1. So left out will be 10 into 9 into 8 into 7 into 6 into 5, or other way what we can write is 10p6, right? So we can see or find option D, 10p6. This is the right answer. If value is given, okay, if value is given in the options, then you have to multiply 10 into 9 into 8 into 7 into 6 into 5 and then select the right option. Here they have given 10p6, 10c6. So right answer will be 10p6. N is 10 and R is 6. Okay, so you have solved the question 2. Solve it on your own once. We are moving on to the solution of third question. Let's solve the third question out of the 5. 7 books are to be arranged in a way so that 2 particular books are always at the first and the last place. Find the number of arrangements. So there are 7 books and they have to be arranged. So arrangements means nothing but permutations. And how you have to arrange? In such a way that 2 particular books are always either at the first place or at the last place. And find the number of arrangements. 4 options are given. Let's try to solve this. Let me draw a small diagram here. 1, 2, 3, 4, 5, 6 and 7. I'm assuming that these are 7 books. Okay, 1, 2, 3, 4, 5, 6 and 7. This particular first book and the last place, right? Last book and the first book will have 2 particular books. Okay, so this is blocked and this is blocked. It doesn't mean that these 2 slots, the one book which is kept here cannot be kept here. Okay, it can be interchanged, but either that book has to be at the first place or at the 7th place. Okay, so these 2 books can change their places only from 7th to first place and first to 7th place. So that's why here in these 2 books cases, n will be 2 and r will be also equal to 2. 2p2 or 2 factorial, that is nothing but 2 into 1 is 2. Fine. This is about the first and the 7th place book. What about these 5 books, right? Second, third, fourth, fifth and sixth. So totally there are 1, 2, 3, 4 and 5. So there are 5 books and 5 slots can be filled here. So maximum possibilities is nothing but there is no more conditions available for these 5 books to arrange however ways you can arrange here. That's why 5 factorial, right? Or it can be 5p5. So the answer will be 5 into 4 into 3 into 2 into 1. Alright. So the answer is 120. For these 5 books the answer is 120, and for these 2 books the answer is 2. So now we'll find out the total ways. Total ways is equal to nothing but 2 into 120, that is 240 ways. Okay, so there is option C, 240. This is the right answer. We have solved question 3. Try to solve this on your own once. Moving on to the solution of fourth question. Question 4 out of 5. Find the number of arrangements of 5 things taken out of 12 things in which one particular thing must always be included. And we have 4 options. So 5 things out of 12 things and one thing must be always included. So let's prepare this solution for this permutation question, and I'm going to make use of a simple formula R into n minus 1 p r minus 1. So one particular thing must be always included, n minus 1 r minus 1. Okay, so here n is equal to 12 and r is equal to 5. Therefore the solution will be 5 into 12 minus 1 p 5 minus 1. Further simplifying this, 5 into 11 p 4, 5 into 11 into 10 into 9 into 8 into 7 factorial divided by 7 factorial. Why is this 7 factorial? Because n factorial divided by n minus r factorial is the formula for npr. N factorial is nothing but 11 factorial, that is 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, and then divided by n minus r factorial, that is n is 11, 11 minus 4 is 7 factorial. So let's cancel this and let's get the final answer. 5 into 11 into 10 into 9 into 8. 5 into 11 into 10 into 9 into 8. The answer is 39,600. Okay, the final answer is 39,600. That is nothing but option C. I have solved this question 4. Try this on your own once. Let me move on to the question 5. Let us solve the question 5 of the permutations topic. If 6pr is equal to 360, then the value of r is dash. We have to find the value of r and we have the 4 options available. First let me write the formula of permutations. npr is equal to n factorial divided by n minus r factorial. This is the usual formula which we make use for solving the permutation question. Given in the question 6pr is equal to 360 and we do not know r. Okay, so let's substitute this 6pr in this npr formula. That becomes 6 factorial, n becomes 6 factorial divided by 6 minus r factorial. Write just r factorial because we do not know the value of r, is equal to 360. So what we can do is we can move 360 to the left hand side and move 6 factorial to the right hand side. The final answer after moving the particular digits are 360 into 6 minus r factorial is equal to 6 factorial. Okay, from here onwards it will be a little bit easy for us to solve. 360 into 6 minus r factorial is equal to 720. So 6 minus r factorial, okay, is equal to 720 divided by this 360, bring it onto the right hand side, divided by 360. So when you cancel this, you get the answer as 2. 6 minus r factorial as 2. So 2 we can also write it as 2 into 1, the answer will be 2 itself, or we can also write this as 2 factorial. So further, 6 minus r factorial is equal to 2 factorial. If we write it as 2 factorial also, it is one and the same. 2 factorial is nothing but 2 into 1, which is equal to 2 itself. Okay, so factorial and factorial we can leave it. 6 minus r is equal to 2. Okay, so r will be equal to 4. Option C is the correct answer. Thank you so much for attending this session and have a nice time.